In the realm of whispers, the answers to life's greatest riddles await. Welcome to Mysterious Whispering. Dr. Lincoln is wrong about the twin paradox special relativity. For over a century, physicists have debated the enigma of the twin paradox in Einstein's theory of special relativity. It seems paradoxical that one twin who takes a journey into outer space and returns home younger than his twin who remained on Earth. But is this perplexing effect merely a paradox, or does it conceal deeper insights into the nature of space-time and aging? Let's dive deeper into this mind-bending puzzle to seek answers. The twin paradox arises from consideration of the asymmetry between two identical twins. One who takes a journey to a distant star in a high-speed rocket and returns, while the other remains on Earth. According to Einstein's theory, the traveling twin should age less during the journey because time runs slower on board the rocket. This is due to time dilation caused by the rocket's high speed through space-time. The stay-at-home twin therefore ages more during the same interval. Some have argued that each twin would perceive the other as moving and thus being time dilated. From the traveling twin's perspective, it is the earthbound twin who is moving away at high speed while he remains stationary. By this argument, both twins should age equally, a paradox. The key to resolving this apparent contradiction lies in recognizing that only the traveling twin's frame of reference is non-inertial due to its required acceleration and deceleration to change direction. Special relativity teaches us that the flow of time is dependent on the velocity of an observer relative to a particular reference frame. It is not sufficient to merely be in motion, one must maintain constant velocity in a straight line to be considered stationary in an inertial reference frame where time passes uniformly. The earthbound twin's frame, anchored to the planet, provides such an inertial perspective throughout the journey. By contrast, the traveling twin's rocket must accelerate away from Earth and decelerate upon return. During these periods of non-constant velocity, time aboard the rocket proceeds at different rates relative to the Earth frame. This results in an overall greater duration of time elapsed for the stay-at-home twin, even though the traveling twin is stationary during cruise portions of the mission. Acceleration and the asymmetrical nature of the rocket's world lines in space-time are thus the keys to resolving the twin paradox. Contrary to some interpretations, the effect is definitively not a paradox, but a genuine physical phenomenon demonstrating the malleability of time under the dictates of special relativity. Aging depends not just on velocity, but the gravitational and acceleration history of one's objectively defined frame of reference. This insight has profound implications, confirming that space travelers truly would age less than their counterparts remaining on Earth or other large planetary bodies. The twins' example highlights how even identical reference frames can diverge over time depending on their relativistic kinematic histories. It also emphasizes that stationary inertial observers provide the physically distinguished vantage points in which to assess temporal experiments. The twin paradox continues to intrigue scientists and philosophers with its bizarre influence of motion on the flow of time. but closer examination shows it involves no true logical conflict, only a failure to fully appreciate relativity's substitution of universal time with a framework of multiple interconnected perspectives. Within that framework, aging asymmetries between accelerated and inertial reference frames are to be expected rather than seen as a contradiction. Resolving the paradox reinforces our modern understanding of spacetime as a dynamic arena where the passage of time depends on an observer's precise vantage point and history of motion through the universe. Does this help explain in more detail how the twin paradox is definitively not a paradox based on the physics of special relativity? Let me know if you have any other questions. There are certainly deeper layers to this thought experiment that continues sparking discussion even today. But I hope this long-form content clarifies the basic resolution by considering acceleration and inertial frames of reference. Please feel free to provide feedback on how I could improve such longer explanatory articles. Thank you for experiencing this whisper with me. Your support helps me keep sharing these mysterious moments. Please subscribe below and I'll see you in the next video.